Hello and welcome again to Steve Long's Tape Workshop. You know the score by now, don't you? Sets looked at elsewhere or got cheap and not working all that well. Come here to be got going if at all possible. And yes, that's Costa is still here. Is here looking at me like I would like. Where's my turn to go back on the bench? Well, it's coming up, but not for a while. Anyway, this is a Micheal Supavox, 2 speakers. And it's also model number 498. So small set, but as I said, with 2 speakers, medium wave, long wave, and so it should be a fairly simple job to get this one to sing or talk to us again. As always with sets like this, particularly with sets with speaker cable as mains cable, which I think that is, always look before you leap. And this is one situation where you don't just go, right, I'm going to plug it in and see what happens. Some cases you can. This one really is a case where I'm going to say don't do that. It's AC/DC. That means therefore that it doesn't have a mains transformer. It has a resistive network. Similar actually to that microphone, and therefore it has U-size U-racing valves in it, and probably look at the edge of it, probably the UL41, UY, UL, UY, that lot. Now because it's not got VHF, it won't have any form of double diode in it, of course. So that is so it's a simple set, and we go inside and we have a close look at what's going on before we do anything else. So that's it. The IF, by the way, it says the back is 465 kilohertz. The fact that that's on the back means that the IF should be obviously not be set anywhere else, but you know, never assume. Always check if you need to check the IFs out. And exactly, yeah. So yeah, it's basically a fairly simple chassis unit. This with one or two interesting features to it. I noticed that the buttons on the side are linked to the chassis by what appears to be a big, because one of them is wave change. So if we now lift it up so you can see what we've got inside it, there we are. It is like I said, it's the UCH, the UCH41 there. Rectifier, 8-put Pento valve, IF. There doesn't seem to be any. There's another one behind as well. That's the IF. So that's the first AF amp on double dyed. As with all these sets, of course, it's always starts with looking and doing it. Having a loop first of all, and then taking it from there. And I might actually power it up very quickly and see what, if anything, it does. I know people aren't supposed to do it, but if you switch it on there and on at the plug first, but be able to pull it out again if something goes awry, as it were, then usually you won't do too much damage. You know, most things you can still get, you know. And these sets, things like 8-put transformers, for example, you can get anything will go in them and work. So you know, no problem there. The problem is the IF circuits, and again there are ways around that, which at some point I will talk about in a bit more detail. Another thing which happens with American sets, by the way, not British sets, is the problem with IF cams, of course, and IF capacitor disease inside them. But again, if we need to do that, then I will look at that in more detail if we need to. If you want to know about that, by the way, then there's some excellent videos on the net about it from Shangle 066's page, so go and have a look at that after you watch this, by the way, not before. And Shangle, if you're listening, it doesn't happen very often with British sets, but I've got some American sets here, so I probably will have to refer to that at some stage in the near future. Right, well, with this set now, there's a plug on, and so without any further ado, I'm just going to plug it in. This is not the way to do it, but I tend to not care about electricity very much. I mean, not everything in life is meant to be safe, is it? So I'm going to now plug this in, and if do one of three things: work, not work, or go bang. So let's see what happens. First of all, going it back, I see first of all that the valves are lighting up. I doubt that you'll see that on camera, but we'll turn the set round and have a quick look. Yeah. And also that tells us that the spring capacitor is dead as a proverbial dodo. So this set is going to come out of its case anyway. But that little test tells me a number of things. First of all, it tells me that the valves are all working heater wise, because of course they wouldn't light up at all. The screws we know about. The rectified tube is doing something, otherwise there won't be any DC toward the set. And the output pen sword in this is it'll probably be UR41. Obviously again is doing something, and the circuit is there, otherwise it wouldn't hum. Also the 8-volt transformer is more than likely okay as well. So that little test tells me that this set is probably going to be, well, it's going to be a go anyway, because nothing comes out of here not working unless it's been moist or something like that, and it's not safe. But this one I think is probably going to work, and work quite well in the end. Also I noticed the gel bulbs out as well. That's not a problem. And also I noticed that it seems to be on a lower tap of the mains on the mains as well, which is on this set here, on the transformer here, on the resistor network here, the balance resistor here. So there's a lot to go up with this, but so far I think, although I will get circuit fed, I probably won't be referring to it all that much. So let's have a look inside and see what we can find, if anything. Never know, we might find nothing very much, apart from what I've just discovered by very naughtily just powering it up. Yeah, I know. Before you all complain, I hadn't my fingers ready to cut the power if anything happened, and it would have almost straight away. So these screws at the bottom now come out, and also the unit in the side there also comes out, and we should then get the set sufficiently out to work on it as need be. Also with sets like this, by the way, the grid coupling capacitor must be changed, because I bet you in this is leaky as hell. That's just something which I know will be the case in this. I notice also the little cracker with the volume control, so maybe there's something else going through as well. But obviously with it doing all that crackling, there's there's more to it than just this, that. Anyway, you know, some sets are easier to work on and take apart than others, and this one I think might be a problem to get apart and put together again. But obviously we'll find out about that in due course. I'm not quite sure how to deal with this actually. Well, that's on a separate. The tuning, the smoothing cap is on a separate circuit here, so that I will probably just leave in place and put new cap somewhere a bit more a bit secret and leave that as it is. Yeah, so now we've got to get this out and see what if I undo that screw there, we might possibly be able to pull the chassis out, because the wave change switch is here, and it goes through here. So I'll take that off for now, and that one I'll leave, and hopefully if I undo this screw here, we might be able to take out the switch here and get the set out of the chassis. Now at this point we look at the set and think, what else do we need to do? Yeah. The other way, of course, is to undo those two there. Take this knob out here, and then the chassis should come out relatively easily. I'm not sure which way. I think the best way to do it is probably that actually. I've got to get in there and take them out. Anything else? It's just those two. Yeah, it's just those two, isn't it? Right, so which way is the best way to do this, I wonder? Hang on, is it up on the front as well? Is it up on the front of this as well? I think there is, isn't there? So maybe something like that has to come off as well, doesn't it? So we'll get rid of that one too. There we are. Wait, now possibly come out. It will come out a bit more. Okay, fine. So it's yeah. Always look and take things apart step by step, so it can be reversed when you put the radio back in the chassis after you've hopefully repaired it. I say hopefully because, you know, hopefully. Well, I've got the thing apart, and I must say at this point that there are certain sets which are rare for a reason. This was a pretty horrible thing to dismantle. They are like that, so I'll take you through it. First of all, the side panel here, that has two screws in between the wave change switch and the volume pot, which has to come off. This has to come off, with links there to there. The wave change switch is in fact there. Knobs have to come off. Aerials have to come partly off. and well, the speakers have to disconnect it because it goes around the back of the unit, it holds it in place. So eventually I got the thing apart, but my God, it was interesting, and I will probably look at it and put it together slightly differently. Now, looking at this, first of all, the first thing that comes to my mind is a screwdriver, this. Yeah. Not only is it on 230 volts rather than 250, with 240 volts here, technically, asbestos. Now, asbestos isn't normally a problem, but I'm not quite sure whether this is or isn't. But I'm not going to take any chances, and we're going to get well and truly rid of it. Now, this means, therefore, that there is a chance here to fit a different sort of dropper. One that will work on AC only, I admit, but sometimes, you know, so what? So this is now going to come completely out of circuit, and from that we're going to fit a dropper unit in its place. So that's the first thing we've got to do. The smoother is going to come out and be replaced, and that's why it's humming so bad. That bulb looks okay. I haven't checked on the meter yet, but it doesn't actually light, so either it's faulty or there's something wrong with the circuit there. That which I put on is technically illegal, so that has to come out and put better cable in its place, and then hopefully we can think about giving it some power and seeing what it does. This one is going to be an interesting one, and interesting ones are good because you learn more from doing interesting ones like this, because an interesting job, of course, is something which you don't always get. So yeah, it was not the nicest unit to take apart, but taking it apart is what I've finally managed to do, and we will from there get the circuit and have a look, and talk about things such as what to put in that place and what to put in the place of the capacitor, which is there in the middle of the set, which is faulty. So a lot to do on this, including a clean. And under the chassis, by the way, the sets of this age, the capacitors that you must change are either Hunt capacitors, or if I can get you to see these things, waxes. They will now go completely. They will now have changed to resistors, and so they need to be changed on site as well. So capacitor changing on this one, as well as everything else. So yeah, it's going to be an interesting one, this, but hopefully at the end of it we shall have a good sounding little set. At which point I'll show you a few interesting ways of sorting out cabinet mistakes, if like me you don't do cabinets. That's going to come. But first, we must get that out of circuit, and we must also bag it up carefully and put it in the neighbour's bin or my bin in such a way as to not being a problem for the dustmen. So that's the next thing. And by the way, after this I'm going to have to have a bath or a shower, because asbestos can be funny stuff. It can cause lung damage, and it was used a lot in those days. So with something that it is used in a set, it has to come out. No ifs or buts. It has to come out, which is the next thing we're going to do. Somehow or other. This has to come out. So yeah, this has to come out. It doesn't matter if it doesn't come out in one piece, because it's not going back in, but it has to come out. And the hair and the chassis underneath has to be cleaned. There's no ifs or buts here. It has to come out, which is what we're doing now. That will keep. The screw will come in from the bottom like that, and I think we'll keep that too. But they have to be got rid of in a way which is better than tucking them in the bin. Very, very important, that. Very important indeed. I noticed some came out on the circuit, so I'll give the circuit a good clean as well. This set is going to take some time, but it should be good when it's done. And what I'm going to do now is I'm going to get the circuit and have a look at and find out what these valves heater change are, and from that I could work out the value of the capacitor to put into here. That's it's usually between 1 and 2 microfarads, but it has to be about right. Now I've done it before with older sets, but again with these sort of sets it is worth doing, because the dropper also gives off as much if not more heat than the valves do, and so it is better a lot of times to get rid of it, which is what I'm doing right now. With that out of the way, now of course this is the capacitor's turn next, and that capacitor I'm going to leave that in place, but put other capacitors in its place in the area as well. So that's the next thing to do. It's only been this before actually, I know, because all this lot is twisted up. So while at it, I'm going to maybe look at this and untwist it as well. So that now comes out. That comes out. That's a transformer that can stop in, but that capacitor is now out of circuit. Right, well this radio is actually a typical Micheal with the 2 speakers. Many had that going well back, so that's something new. But I've only got one connected right now. I've got the radio out of the case, just about. It is not a user-friendly design, so I would say. And also in this case it's quite dangerous. Look at this here. Yeah, it's only a 1-pole switch, and that pole is in the neutral. Yeah, so with the radio switched off, the inside could still be live, because in those days of course could plug in either way as well, or even go into radios, going into light sockets, and so this radio could be switched off, what's inside could be live. You know, in those days, people knew about such things and handled them with consummate care, but nowadays things are a bit different and people don't know the same. And the electrical safety regulations are more strict these days. You could have grandfather rights on this, I know, but with electricity in this case doesn't matter. So what I've done here, I've taken the dropper out and the asbestos washers, and I've built something called a wattless dropper. That's this thing here, and this is a capacitive dropper, and what it does is it drops the same amount of mains, but it doesn't generate any heat. This means therefore the radiator will not get as hot, but it will still work. And it first came actually in the 70s in a BRC 1580 TV, but it does work on radios, and it's quite a good way of dealing with this problem if it occurs. So a lot of the resistors check out okay. I think that is a better solution, so that's going to go in. But also with this, the switch is in neutral, so that's going to swap round. So now it's going to be a positive dropper there, the valves, and that will go to deck. And so that bulb is now out of circuit. So deck is tied straight to neutral. That bulb's out of circuit. What I'll do there, by the way, is I'll put a neon in or something to light the dial. It'll look the same, but it'll be a lot safer. Also, capacitors are here as well for the hum, and the others to change as well. So that's where we're up to, and now of course I'll get on with it, which I've done so far. What I've done is I've taken out a lot of the wiring, all the old wiring. That will now be a light switch rather than a neutral switch, and the valves have been out and checked, and they all appear to be okay, as in they light up. And underneath here there's a choke, that's a resistor in between the two capacitors on the smoothing, which is if we can have a look, can we get to see that? There. I'll see if I can bring it in a bit. There. That's a choke between the two smoothing capacitors. Well, a smoother and reservoir cap, and they will go onto there today. There's plenty of places today, so no problem there. And of course, the smoothing, the transformer for the speakers, the 8-point transformer, is in the back here, so that has to be connected as well. Also, while I'm here, some of the capacitors will go and be changed as well, and then we'll see what we get. Right, in front of me here, a few notes about how capacitive droppers work, so we're going to go through it. AC/DC sets only, this is, by the way, these are sets without a mains transformer. Sets with a mains transformer, the valves are in parallel, so this doesn't work, but only with sets with the valves in series, which, apart from one or two exceptions, are AC/DC sets. This, by the way, is for people in the UK. In America, it's a low voltage, and also it's 60 hertz. So when I say 100, and for that it'll be 120. Apart from that, it is about the same per process. So first thing you do is you get the valve heater volts of every valve and add them all up. Come to 115 volts in this. That's UL41, UY 41, and the others. It comes to 114 point. Well, I've raised it to 115 volts. Okay. The valve heater current, by the way, is the same on all the valves. It has to be the same on all the valves. In this case, it's 0.1 amps. Okay. Now, you can't just add the valve heaters and capacitor together, because capacitive resistance or reactance is 90 degrees behind resistive. Okay, remember there's there's a word you can remember, civil. Capacitor, current follows power, and voltage follows current in a coil. That's civil. Okay, alpha coil, by the way, otherwise we can't have them both called C, can we? So our coils are L. Now because of this, you can use Pythagoras' theorem. So all these stuff you'll learn at school, now there's a use for it, and that use is this. So your maths teacher at school might have been an idiot, but he taught you some good stuff. You should have listened, shouldn't you? But anyway, if you take the hypotenuse of I think a triangle, that's the line opposite the right angle. Take that as mains voltage, which is 240 volts. 239 here. I still use 240, although you can use 230. You know, again, that's up to you. V8 is the voltages which I added together just now. Now, Pythagoras' theorem states that the square of the hypotenuse is equal to the sum of the square of the other two sides. Remember that? So the square of the hypotenuse is equal to the sum of the square of the other two sides. Yeah? So therefore, turning that around, VC, that's the voltage dropped across the capacitor that's going to go in there, is the square root of all of mains voltage squared plus the square of the voltages added together. Okay. Now V in squared we know it. It's 240 squared, which is 57600. Okay. And V8 is 115 squared. It's the square of all the valves. So that is how that works. With that, of course, you should be able to get voltage across the valves. Now the current, as we know by Ohm's law, is 0.1 ohms, and from that we can find the resistance, or capacitive resistance, or reactance, which is XC, which is what we need. Now, resistance or reactance of a capacitor is 1 over 2 pi FC. Turning that around, the capacitive value we want is 1 over 2 pi XC. Okay. Now 2 is a constant, pi is a constant, and 100 volts is a constant. So therefore, the capacitor you want is 1 over 214.2 XC. Now from that, of course, that gives the value in farads. You want it in microfarads, so you multiply by 1,000,000. And that, of course, gives you the capacitance you want in microfarads. Now, you might not be able to get exactly right, but connecting 2 or 3 capacitors in parallel, it might well go to, certainly within the parish. That's how you do it. Now why use one of these? They run cold. They don't run hot, they run cold. And I changed it in this one because the resistor that was in it before had asbestos around it, so a whole lot to come out for that reason alone. Now here you see you've got the voltage of the valve adding up to 115 volts there, and it comes out at 1.55 microfarads. Yeah, 1.55 microfarads is a 1.5 and a 0.047. That will add it up to very, very close, and that's what you need. So that is basically how you do a capacitive dropper. Very easy when you know how. By the way, if you want to know more about this, then there is actually a spreadsheet on Paul Stenning's page, vintageradio.com. Go down to dropper resistance, dropper calculations, or dropper something, and what that tells you about all 3 mains ways of dropping resistances. Capacitor is the middle one, and the spreadsheet there if you don't want to go through all that. But basically, that is how you do it, and it goes in between all the valves. Now, one thing that does happen is that the valve take a little bit longer to warm up, so be ready for that. Right, well, at this point, the radio is now safer because the switch is on the live line, and of course it'll run cooler as well. Now if I plug it in right now, like so, you'll hear anything because the HT is not connected. Now sometimes with these sort of droppers, occasionally the valves take a little bit longer to warm up, but to warm up they do, and they work just as well like this, so there's no problem there at all. All we've got in the circuit at the moment across the mains is the switch, the capacitive dropper which is here, and the 4 valves, and as you can see here, lighting up. I'll just turn that off there, maybe you can see them now. They are lighting up. I'll just see if I can come a bit closer, so and see if we can actually see that on the camera. Now, because they're all lighting up, we know therefore that all the heaters are working, and although the radiator is doing nothing there but lighting up 5 valves, there is nothing else it can do because the HT is not there. So now we put the HT on. Before we do that, of course, we have to make sure that the set is okay to receive HT, which is what we're going to do now. That capacitor has been disconnected because it's faulty, and there will be 3 capacitors underneath here as well. Also, there are some caps in this circuit which I will just take out because they're not really needed anymore, and 1 or 2 which I must change, and then we can plug it in and we might even get some music. I found the problem with this set now. The volume control is out of the set. The circuit says it's 1 meg. This is considerably less, so it's been changed at some point, I think. So I'll try and get a 1 meg pot that will go in there. But for now, even with the capacitive dropper, and now you can see the extra time it takes to warm up. Not very long, but here we go. Now, initially I looked at testing the IF first, but when I put it on, it rather proved the point that maybe I should just let it switch on and see what it does. The aerial is on my meter, very handy tip that, by the way, and when it's warmed up, here we go, it's making some noise, and that's a quiet station, by the way, I don't know where it's from. With this, right, well, the band.
That was the thing.
Look at that. So I'm fairly sure that we don't.
Cinema, to gigs and galleries, the gym, the
Fairly sure that we don't need to muck about the tuning side of it. So I'm not going to.
And get back to the things we love. If you're feeling unwell, get a free.
So there you are. It's now working. Now I've got to put the volume control back in. Like that one. And make it safe, and the job is done. Well, at this stage now we have the set ready to test again. I've put the correct value of pot in here, and I've not put the mains across it yet. So now when we plug this set in again like that, wait for it to warm up, then we should have, I hope, noise activity of some kind. Probably music actually, because I was listening to it last night on Gold, which is the station I used to. Here we are. And so there's they're going further forward with it. That's Virgin. The voltage is set very low by the way at the moment, so that's probably why. So at some point now we should come into a talk station.
Oh, you've done yourself a massive disservice.
That's talk rate. That's talk sport, by the way.
Oh, what if I need to check this though, just to clarify that?
Where they talk about sport. So now I shall tidy up the work I've done, and then at that point we'll try it again. We always, when we tidy the radio up after something like this, do a bit, do a bit, test it, do a bit, test it, do a bit, test it. This is because, unfortunately, things do go wrong, and this set is rather old, and it has been much about it, before it being much about it was by me, and it was not the easiest set them all to get apart. Well, at this stage now, although you can't see very much of it, I'll turn the set around a bit so that you can. There you are, and I've put the light in there. I actually now got the set partially back together. Both the speakers are connected, and it's actually in. All that's left to do now is this and this on the wave change switch. But as you can hear,
Lift the trophy. It was just an amazing feeling.
it does actually work. So
Captain Jordan Henderson.
always, like I said, always check every step of the way with reassembly. Check the radio, and check the radio fully and carefully as well, because particularly with a set that's been modified like this one, you never know quite what problems may occur. So yeah. Anyway, on we go with it, and I'm going to bolt this onto here now to fit the wave change switch on, put the back on, and then all is well. So I'll get on with that. And again, the reason why I'm not doing this on camera, by the way, is because of the language I use. Because, as you know, I've only got one arm. I'm disabled, and it's not easy sometimes to do things like this with one arm. Believe me, it's not. Anybody who wants to have a go at me for it, then do so. But you know, I really don't want a fight with anybody over anything. But there you go. If people do, well, you know, try it with one hand and see what we get. Yes, I've had some comments. Deleted, of course, but I have had some comments. The job is done. Special thanks go to Andy at Vintage Electronics Repair here, because these sets, although they're quite simple electronically, as far as getting them apart is concerned and putting them back together again, they are not the easiest set in the world to do. Andy had trouble himself at one point, but it's all back together now. It's not nothing too complicated on putting that, being able to take it apart side, but there are a few things on it in it which really should be thought about rather better. For example, you disconnect one speaker and pull the wires out, and take the wave change switch off before, as well as the wires underneath, and the tune knob at the front there to get it to work. This set does work very well.
Representing Scottish football, a calamitous night for the club.
There you are.
Well, I think
Actually, it's also got a rather interesting. It's got.
They have said to us that
Needs me to go back now.
administrators would be really
It's
pleased
slower,
if you could leave this situation.
so you can see, you can tune it. Like that. And also smaller stations. That's the Q103 station number 2 there, which is Baby said managed to come to here very well. And of course the usual set that I listen to, the station, is that one, which is okay as well. But like I said, I couldn't have finished it with Andy, so thank you very much for that, Andy. Bean up, I owe you one there, buddy, and thanks for your help with it. Difficult for me because I've only got one hand, but there you go. So it is nearly done. Well, I've done as far as I want to, because I really have had enough of this set now. I really have. Problems it had include having the wrong pot on the volume control. 1, 2 caps, obviously, the smoothing cap, and surprisingly a Duff valve, a UL41, which had a heater cathode shock, which I've also achieved. So also with this one, as I said, it's now got a rather different and cold running heater dropper circuit in, which I told you about earlier on. Quite a good set. They look good, but they're very good, by the way, but to use them, great. But if you get one of these and you're not sure, I would say be very careful of it mechanically, because it's easiest for me to do the mechanical, the electronic parts and mechanical. That's all I got one hand. But it's good now anyway. So until next time, goodbye, God bless, whatever your God is, and keep fitting radios. Bye bye.